get me connected and ready to go. So we're going into lesson 4 today, and I started looking at the lesson, and I decided that I am going to do page 2 with you guys today because the homework, the first page of the homework more focuses on page 2 of the lesson. So I'm going to switch it around. I should have switched it around in the notes, but as long as you guys are watching this video, you should be okay. So we are going into a new thing called radians. So again, I'm going to skip over page 1 for today. We're going to go back and do page 1 tomorrow. I'm going to jump down to the second page. And I'm going to talk about some conversions. I'm going to talk about what radians are and blah, blah, blah. Okay? So just waiting a little bit since it's only a little after 3. It looks like a few people are still jumping in. Hey, what's going on, Tabitha? I don't know if I should say that it's sad that I am your entertainment of the day, that you're going to eat popcorn and watch me teach math. But, so I don't know if that is a compliment or not. It says, I guess the only thing that I should be doing from the first page to help us out for the second page is the biggest conversion for a circle, because you guys have never done any conversions between degrees and radians before. That's what the new thing is for today. What we were going to learn on the front page, and I guess I do it in one exercise. I'll just draw a picture of it so you guys can see it off to the side. If we have a full circle, you guys have always been taught, where did the circle go? Come on, circle. So if you have a full circle, you guys have always been taught that that is 360 degrees for a full spin. And in radians is just another form of measurement. It's like saying how we convert inches into feet. It's like how we convert like miles into kilometers. That's all we're kind of doing today. Radians are kind of important when you go to upper level math classes, because it's easier to solve with radians than it is with degrees, because degrees you'd be working with much bigger numbers. Radians you could work with smaller numbers, and it's easier to calculate. Otherwise, if you don't plan on taking pre-calc or calculus in your future, this radian stuff, I'll show you guys how to do it on the calculator for the most part. So you guys should be all right. We'll just kind of go day by day with it. I'm not going to go too crazy with it this year, but if you do plan on taking pre-calc with Miss Randolph next year, then yes, you're going to probably do some more with radians. But all I wanted to say is 360 degrees is the same thing as saying 2 pi. And the reason why is when you start working at the circumference of a circle. And the circumference of a circle is when you start doing, when you start looking at pi d, it's the distance around, but it's also looking at angles. So we'll talk more about it tomorrow on the first page. I'll just leave it at that. For now, I just want to show you guys the conversion to show you how to do the first page of the homework. Okay. Sierra, listen to Isabel. Go to Isabel. She'll tell you what to do, and then you can get up to 3 stars. As far as what we're going to do here, so we have 360 degrees is equal to 2 pi. So on the left side, this is represented by degrees. This is what we've been doing since day 1, since we've started working with our shapes and stuff. It's always been degrees. The right side is this new thing. This is called radians. So let me see which side that we're solving for. This wants us to go from degrees to radians. Okay. So what I want to do, if my iPad will unfreeze itself, What I want to do is I want to make it so the degrees is equal to 1 because we're trying to convert it into radians. Okay? So if I'm trying to convert it into radians, I want this side all alone. We want everything over on the radian side so we can convert it, so we can figure out what this conversion is going to be. So what I'm going to do to both sides of this equation up here is I'm going to divide it by 360 degrees. Because we want to know how much 1 degree is worth in radian mode. This is very similar to what we do when we're talking about temperatures. When we're doing temperatures, you guys have, like, for example, I always start off at 32 degrees Fahrenheit because that's what we use here in the US. But if you go to another country, they're using Celsius. So I would ask you guys, hey, what's equivalent to 32 degrees Fahrenheit? And hopefully you guys know that 32 degrees Fahrenheit is the same thing as 0 degrees Celsius. So what you're doing is you're doing a conversion from one to the other. We're doing the same here. We just want to know how much 1 degree is going to be worth in that radian mode. Well, if you have 2 pi over 360, that can be reduced because both top and bottom can be divided by 2. And if we divide both by 2, we would have pi over 180 degrees. Okay? So pi over 180 degrees is equal to 1 degree. And that would be our conversion. So I know this isn't going to make a lot of sense on day one. So right now, I just want to make sure you guys understand the math. You don't have to understand where this pi over 180 came from. I just want to make sure you understand the math for the conversion. So in A, B, and C right here, it says convert each of the given angles from degrees to radians. So what I'm going to do is if I know that I have 90 degrees and I know that 1 degree is pi over 180, if I multiply them together, that will tell me how many radians I would have if there's 90 degrees. So what I'm going to do is I'm just going to multiply this by pi over 180. And again, we're doing that because this right here is representing 1 degree. Pi over 180 is 1 degree. So we need to know how many radians 90 degrees is going to be. So what I'm going to do is I'm going to take that 90 degrees, I'm going to put it over 1. And we did something with fractions going back a few weeks ago. I mean, I keep saying a few weeks. This was a month ago now. We did something called cross canceling. So if you have 90 on top and 180 on the bottom, you can cross reduce those because both of them 90 degrees fits into. So I could divide this number here by 90 and I'll be left with 1. I can divide the bottom by 90 and I would be left with 2. So if I wanted to convert 90 degrees into radians, I would be left with pi on top and I would be left with 2 on bottom. 90 degrees is equivalent to pi over 2. This is now radian mode. So again, a lot of you guys are not going to understand this whole purpose of radian thing. Just understand the math today. Just understand the multiplying and what we're multiplying by. That's the big purpose of today. We'll work our way into why radians are important, why I'm teaching them to you as the lessons progress within the next week or two. Okay? So the same thing's going to happen in part B. So we have 120 degrees. Now our goal is to convert it to radians. So anytime we want to convert to radians, the rule is to just multiply by pi over 180. So anytime you want to do that. And the one nice thing, and I say it's a nice thing, but you guys don't have to take the Regents exam. If you do plan on wanting to take the Regents exam in August or next year because you're trying to go for the Advanced Regents diploma, Advanced with honors, you don't have to memorize this. They give this to you on the exam. No, so Ella, you might have jumped in a little late. I'm skipping over the first page today, and I'm going to go back and do the first page tomorrow. So I'm flip-flopping it. Um, so if we go to do 120 degrees and we convert that to radians, all I'm going to do is multiply it by pi over 180. So basically, it's just the same exact process every single time. So I'm going to put the 120 over 1. And now, again, I want to cross reduce it. So I'm just looking at the 120 and the 180, and I'm trying to figure out what I can divide both of those by. I'm trying to look at it. It looks like I can do 10, and I'll just do 10 for now. So if I do divide both of those by 10, that means this is going to become 12, and this is going to become 18, if this wants to write. There it goes. All right. And then we have 12 and 18, and 12 and 18 can be reduced down again by 6. So if I cross off the 12, that would become 2. And then 18 divided by 6 would give me 3. So we have 120 degrees. If we want to convert that into radians, we have a 2 pi left on the top and a 3 left on the bottom. This would be equivalent to 120 degrees. They're the same thing. It's just being converted into a different form. Okay? It's just a different unit of measure. And again, we'll go a lot more into this in the future. Last one, we got C is equal to, or C is theta is equal to 225. I'm going to do the same exact thing. I'm going to multiply it by pi over 180. And I just want to show you guys something. Some of you guys are not going to be able to do the math off the top of your head. So if you put it over 1 and you can't cross cancel it, you can just write it as 225 pi over 180. And I'm telling you guys right now, that can be reduced. You can just type it in the calculator to reduce it. You don't have to do it off the top of your head like I did in the first two. So what I'm going to do is I'm just going into the calculator. Just remember, you cannot type pi into the calculator, because if you type pi into your calculator, you're going to get a crazy decimal. You're only allowed to type in the fraction itself. So I'm going to do 225 all over 180, and it's just going to reduce it for us. It's going to say 1.25. I want it as a fraction, so I'm just going to hit math, frac, enter, and it says it's 5/4. So this is really going to be 5 pi over 4. And if you don't remember how to do something on a calculator and you want help with it, don't be afraid to ask me. Shoot me an email. I know some people forget how to change it to a fraction. That's the math button. Again, if you need help with it, just let me know. So for those first three, we converted them all into radians. The bottom of the page is just going in the opposite direction. So now what we want to do is we want to solve it for 1 radian, not 1 degree like we did up top. So if I want to take the same little formula, because I told you guys 360 degrees and 2 pi are the same exact thing. Okay? Or just keep it the same. Yeah, you can do that, Ella. So in this one, we want to get the radians all by itself. So again, this side is radians. This side is degrees. So we want to get radians equal to 1. So in order to get radians equal to 1, what I'm going to do is divide this by 2 pi. Because 2 pi divided by 2 pi is just going to be 1. Well, whatever you do to one side, you got to do to the other. Well, if we do 360 divided by 2 pi, again, we could reduce the 360 and the 2, because 360 divided by 2 is going to be 180. However, we still have that pi on the bottom. So you guys should notice one little thing happened when we worked backwards. Up here, when we started with degrees and went to radians, the conversion was pi over 180. But if you go backwards, the fraction flipped over and became 180 over pi. So depending on how the question's asked, you have to know which way the fraction's going to go. So up top, we did degrees to radians. So we went from left to right. So I'm just putting a little arrow in there if you're having a hard time seeing it. Now down here, we're going to go the other way, and now we're going from radians to degrees. We're just going backwards. So if you go backwards, the fraction's just going to flip over. So now I'm giving you all those answers in radians. So what I'm going to do is I'm going to multiply it by 180 over pi this time. So I'm just flipping it over. And now I can do the same rule that I did before. I could cross cancel. Or some of you guys may want to just multiply straight across because you have the calculator. So I'm going to multiply straight across because I know a lot of you guys are going to prefer using the calculator when you go to do this. So I have 5 pi times 180. Again, don't type the pi into the calculator. So I have 5 times 180, and that's going to be 900. So I'm going to have 900 on the top, and I still have pi on the top, all over 6 times pi, which is 6 pi. Well, now we can reduce this. Since we have pi on top and bottom, we're allowed to cancel both of those out. So now all I have to do is 900 divided by 6. Oops, I was doing it right. Alpha y equals 900 over 6. And it tells me I'm going to have 150 degrees. So 5 pi over 6 is the same thing as 150 degrees. So again, as you guys are watching this, I'm just hoping that you guys are going through and you guys are feeling comfortable changing it into degrees or changing it into radians. You don't have to have an understanding of why right now. I just want to make sure you guys have the math. What's up? What's up? So I'm going to do one more and then I'll go down and do the last one. So if we go to part B, we got 3 pi over 2. So again, this time you're being asked to change it from radians to degrees. So if you're changing it from radians to degrees, we're multiplying by 180 over pi. So we're going backwards. Yeah, Tabitha, if you want to do it with cross-canceling, that's fine. So I'll cross-cancel in the second one. It's okay. I was just showing that you can multiply straight across or you could cross-cancel. Either way is fine. It doesn't matter which way you guys do. I'll cross-cancel on part B. So if we cross-cancel in part B, if I look at the 3 pi and I look at the pi, the only thing that we're allowed to cancel out in this case are the pi's. So the pi's are gone. If I cross cancel the other part and I look at the 2 and I look at the 180, we can divide both of those by 2. So the 2 is going to cancel out and become 1, and the 180 is going to cancel out and become 90. So now we could just multiply straight across. If you guys were to do 3 times 90, that would be 270, but everything canceled out on the bottom, so we're just left with 270 degrees. So if you prefer cross-canceling, you are more than welcome to do that. That is the preferred method. The first one, I just did it as if you were doing it with the calculator because I know some of you guys can't do a lot of the math off the top of your head. So either way is acceptable. I don't care which method you guys use. Okay? So, exercise number 6. It's the last one I'm going to do with you guys. Because part C is going to be the same thing as A and B. You just have to multiply it by 180 over pi again and then cross cancel. Number 6 would be a very, very popular question on the multiple choice version of a Regents exam. So it says an angle is drawn in standard position whose radian measures 2 radians would terminate in which quadrant? So they just want to know, is it going to be in 1, 2, 3, or 4? Well, we know that we have 2 radians. Now, I have never taught you guys how to graph with radians. I don't even know how to graph with radians off the top of my head. It's not something that's easy. It's not something that's fun to do. So my recommendation is anytime you guys are given radians and they tell you to graph, convert it to degrees, because degrees is much, much easier to graph. So what we're looking to do here is we're looking to go from radians to degrees. Based on what we just talked about towards the top of the page, in order for us to go from radians to degrees, that was the second part. That means we're multiplying by 180 over pi. So since we started off with 2, sorry, I hit the button on top, so my iPad just went to sleep. If I have 2, I have to multiply it by 180 over pi in order to change it into degrees. So if I change this into degrees, I'm going to put the 2 over 1. This one I can't cross cancel because 2 and pi, there's nothing that can cancel out. 180 and 1 can't cancel out. So I'm just going to multiply straight across. So if I do 2 times 180, that's going to give me 360 if my iPad doesn't want to write right now. There it goes. 360 all over pi. But still, I'm now looking at that answer. It's 360 degrees over pi. If I were to give you guys an X and Y axis and I ask you guys, hey, graph this for me, that's not something you guys know how to graph off the top of your head. The only way you're going to be able to graph 360 over pi is if you actually divide it out in your calculator. So I'm actually just going to type in 360 divided by pi, and it's going to come out to be 114.591559, and it's going to go on forever and ever and ever and ever. So we're just going to kind of estimate. I'm going to say it's about, so I can't say it's equal to. I don't know if you guys recall in geometry, when you estimate, you have to draw like a little squiggly equal sign. That's about 115 degrees. Well, now that we're at 115, if I were to ask you to graph this, you guys should be able to tell me what quadrant that's going to be in. 115 is just going to fall in quadrant 2. It's going to be somewhere up here. So all I wanted to know in this question is what quadrant it would be. It would be in quadrant 2. So sometimes you're going to have to do a conversion before you graph. If you were to look at your homework assignment for tonight, and if anybody has questions, I'll come back to it. I just wanted to pop up the homework questions. So I'm going to homework number 4. And when you guys go into this homework, I accidentally made it say homework number 3 for some reason. I don't know why. It's supposed to say number 4. The first one tells you guys to convert from degrees into radians. So that was like the first part of the lesson that I just did. No, Maggie, I didn't put it in yet, so I'll make sure to enter it in a second. And then number 2 is asking you guys to go the other way. So this one's saying go from radians into degrees. And then the last one, you're going to have to convert it into degrees first. And then tell me, it says determine the reference angle. So I want you to just, no, you know what? I don't want you, yeah. We'll do reference angle because that's what it says. So it says determine the reference angle. So make sure after you guys draw it, tell me what the little angle is going to be in the right triangle. So this homework is not due until Monday. Okay? So this homework is going to be due on Monday. That would be May 4th. So 5/4. So that's just the front page. I'm still going to do the front page of our notes, and that'll help you guys out with the back page. And I'm going to tell you guys right now, don't worry about the Regents review questions. The fact that you guys are not going to be taking the Regents, I don't care about those last 2 questions. You guys cannot do numbers 5 and 6 until I do the lesson with you guys tomorrow. So at least for this homework, you'll be able to do the entire front page for now, and then you can do the back after tomorrow's lesson. The homework number 3, technically, I didn't realize and never put it on Shobi. Technically, the due date was 9 o'clock tomorrow. So what my game plan is, I think I mentioned it yesterday in the lesson, but every homework is going to be due on Thursday and Mondays. Okay, so homework number 3 will be due tomorrow. Homework number 4 will be due on Monday. Okay? So if nobody has questions as far as the conversions go, that's all I got for today. All right, so once I end the stream in a couple minutes, I'll jump into Shobi and I'll add in homework number 3. So if you guys have that done, you can add it in there. Again, make sure you guys are keeping up on any other missed assignments if you haven't done them yet. I sent emails out to everybody that's kind of been inactive for the last couple of days or last week or two. I think everybody that I'm seeing in the feed right now, everybody that's here has been showing up, so I'm not really worried about you guys. But yeah, that's all I got. So I hope you guys have an awesome day. It is actually kind of nice today. I thought they were calling for rain, but I think they pushed it. So go enjoy yourselves. And then hit me up in Zoom or email if you guys have any questions. Okay? So I will catch you guys later. See ya.